Good morning. So, what we are going to study at the moment is differential equation, and what are the topics which are important in differential equation. Let's start with the chapter differential equations. So, what does the word differential equations means? The word differential equation mean is suppose this is the type of equation that we are dealing with. Of course, this is not a linear equation because it is contained in degree 2 and there is a multiplication of dependent terms. So, this is a differential equation. Why it is a differential equation? Because it contains dy by dx in any form, maybe it d square y by dx square or anything. So, it contains dy by dx. If it contains dy by dx in its pure form, not partial form, then it is called ordinary differential equation. And partial differential equation is not in our syllabus. So, ordinary differential equation, this is the ordinary differential equation. It is very important because the questions from here are basic, solvable, and you can get good marks from here. So, this is the main reason why I am doing this thing. So, the next thing is this I did. The next thing is one more second. Now we will jump to the second is order and degree of differential equation. Order and degree of differential equation. So as I said that this is the differential equation. So what is the order of this? Order is the highest derivative present in this. So the highest derivative present in this is 2. You can see d square by dx square. So the highest derivative here is 2, and degree is the power of that biggest thing. So the power of that is 2. So order is 2, degree is 2. Yes, power is 2, degree is 2. Degree and power. And one more thing we have to remember while deriving the degree and power is degree and order is there should not be a term like cos y, a function of dependent terms, because at the moment if this was here there was going to be no problem, because anyway this is going to be the highest derivative and power is 2, so order and degree remains true. But if it was case like this, cos of this, then of course that this expands like this. This expands like this, where x is equal to d square upon dx square whole square, d square of dx is to 4. So here we can only find that order is equal to 2, but degree is equal to infinite. So this is the main reason why we have to expand first. We have to remove the we have to remove the function of the dependent variable. Maybe it cos e raised to y, ln y, any such form like this. So this was all about degree and order of a differential equation. Now the next important thing here is there are 6 methods to find the solution of a differential equation, and the 6 methods namely are and why they are different. First, in all these 6 methods you will maximally find this dy by dx. you won't even find this. So maximum you find only dy by dx and not even d square y upon dx square. So the six methods are: first, variable separable method. Second is uh, convertible to variable separable method. Third is homogeneous differential equation. Fourth is convertible to homogeneous differential equation. Fifth is linear differential equation. And sixth is convertible to linear differential equation. And seventh is exact differential equation. So these are the seventh method, and in the next video, which is named to be differential equation 2, so we are going to continue. Thank you. First, let us discuss what linear differential equation is. So linear differential equation. So the previous equation which I did was this. So why this is not a linear differential equation? First, let us understand this. This is not a differential equation because it is contained in degree 2. Order can be anything. Order can be anything, but degree should be 1. Degree should be 1, and the second point is it is containing this y dy by dx. This is problematic because there should not be any multiplication of the dependent term. If it was like x square or ln x or x y or x square y or x square dy by dx, anything of this form was acceptable, but there should not be a multiplication of dependent terms. So this was the main problem, and the third problem is it should not contain function of y like cos y. One function of dependent term like ln y, e raised to y. All these things it should not have. So if it follows all this, then it is a linear differential equation. And linear differential equation is just necessary in that linear differential equation, linear form of Bernoulli equation. Other than that, it is not useful. Now the thing which we are going to study this 7 methods. In the 7 methods, what we will maximally encounter is this dy by dx, not even whole square, just dy by dx, not even d square y by dx square. We'll encounter all this. So the first method of that 7 method was variable separable method. So how the question will appear and how will you identify the question belongs from variable separable method? So by looking at the question, you will be able to identify that is the terms like x and y are separable. If they are separable by doing anything, if they are separable and completely separable, so dy into y is equal to x into dx. This step occurs, then integrate both sides, and you will get the solution. But sometimes the second method was reducible to variable separable form. The thing is, sometimes you may feel like yes, this is convertible to variable separable form, but due to something it is not getting converted, so you have to find that something and replace it. Suppose like y by x is equal to z, or x by y is equal to z, or x plus y is equal to z, or x minus y is equal to z. So this is the form of convertible to variable separable form. The third form which we encounter is homogeneous form. Now what remember in all this we will maximally encounter this dy by dx, only dy by dx. So in homogeneous differential equation form, replace x by kx and y by ky, and if it appears in after processing it, you find that all the k are cut and just the initial equation remains, then it is the homogeneous differential equation form. And advantage with homogeneous differential equation form is, no, it cannot be solved by variable separable, because sometimes it contain terms like x square y cube upon x y raised to 4. So means suppose something like this. So not every time it is a variable separable form. So for this you replace x is equal to vx, y is equal to vx, and remember v is not constant for this. So y is equal to vx. So if you do like dy by dx, it comes as like v plus x dv upon dx. It should go like this. Or you can also replace x by y is equal to v. Yeah, remember dy by dx is equal to 1 by dx by dy. That and the thing the teacher told in class 12th, he was an idiot. He did not know math. He was just dumb, and he was trying to be just like, he was trying to act smart and shows that he is smarter in mathematics. No, he's not. Dy by dx is equal to 1 by x, 1 by dx by dy. It is fully valid. Now the next two methods are, the thing is, linear differential equation form. So and it is also called Bernoulli form. Bernoulli form appear like this. This recorded in the next video. Thank you. Now the next form is linear differential equation form. Now how the or it is called Bernoulli equation. Bernoulli's equation. How it will appear? It will appear like this, or maybe dx by dy plus px is equal to q, where p and q are functions of x, pure function of x. There is going to be no term of y, pure function of x. And here in this there will be pure function of y, pure function of x, of y. Understood? So this is the thing. In most of the question, as we have I have seen in previous year question, it is directly given in this form. So p is equal to, now the next step is if is equal to integrating function is equal to e raised to p dx, e raised to integration p dx, and the solution will like q into if dx, dx. Yes, this is the thing. Now you know convertible to linear differential equation, it will appear like this. It will be something like this. So, what I'm doing, something like this. Now this is converted into the usual form. So t is equal to some function of x will be answer, and replace t with this, and you will get the relation between y and x. Now the third form which appears is don't worry if there is ln, like log y. In mathematics we don't use log, it is ln by upon y x plus something, and you will get like so. This was convertible to variable separable form and all this. The main important thing is here exact the seventh is exact differential equation. Now what is exact differential equation? The thing with exact differential equation is it appears a form like this. M is function of x and y, n is function of x and y. Now the sometime it is like Udaipur given, so don't worry. dm upon dm upon dy is equal to dn upon dx. If this both are equal, then this is called exact differential equation. And don't worry if suppose here dx dt is given, here dz is given, you don't need to worry, it will still be same. The first given will act as x, the second given will be act as dy. The first term will act as dx, second will act as dy, and at the right hand side it should be 0. So this is the linear differential equation form, and if this is, then it is exact. Now the solution of exact differential equation is m dx plus ny dy is equal to constant. Now what is m? Here is of course this, but consider y as constant in dx. In m there it is function of x and y, so consider y as some constant term and then integrate only x. Here if as y it is given, if any x appears in any term, maybe it like x square y, x ln y, or anything, if x appears, then completely neglect that term. Any y can be in any form, but if x is present in that, then completely neglect that term, then is equal to constant. So these are the 7, and when to use this 7. When we have to use this 7 is first maximally dy by dx is given, and this exact it can also be solved by variable separable form or homogeneous form. Sometimes you have to use this 7 when first you maximally see dy by dx only. Second, in that later stages, d square y by dx square is common. Dy by dx is least common, is not so common. So if you see any dy by dx term, then first thing about this 7 can only be used when dy by dx is given. If d square y upon dx square is given, then this seven methods cannot be used. So use this method accordingly only when dy by dx is given. So there are no hard question in this, and maximum you will be able to visualize which to use, and should we go to the higher. Some questions of this can also be solved by higher, but in higher there is a catch. We will see it later. Thank you.